Hi everyone, welcome and thank you for joining our webinar on using drones and AI for invasive plant species detection and control. I'd like to begin by sharing an alarm statistics with you. Invasive plants have had a major economic and social impacts on our agriculture, natural ecosystem, property values, and more. In North America, their cost has grown from about 2 billion per year in the 1960s to over 26 billion annually since 2010. Could the use of the advanced technology help us save money and time in this critical battle for our natural resources? That's what we are here to talk to you about today. We're from KCI, a leading civil engineers firm, and our team is part of the Innovation Product Group. We are promoting a pre-trained AI platform for the AC industry. Our goal for today is to share use case of the drone technology in invasive plant management and to demonstrate our model, BRYX PhragFinder, which is use drone images to identify invasive phragmites. My name is Jay Kong, and I'm a sales engineer, also with Kathleen, product managers, Carl, system engineers, and Samantha, which is project manager from KCI service team. We are ready to present to you guys today.
Hi everyone, I'm Samantha and I've been with KCI for a little over 11 years and my work has landed me very heavily in invasive species management, specifically the technology to manage invasive species. And in 2018, I added becoming a drone pilot for KCI to my list of things. But before all that, I took an interest in remote sensing when I tried to find a few tree islands that I had done in undergrad research and forgotten to take the GPS points. So all of this kind of started because I forgot the GPS. Eventually, I was able to identify tree islands by using satellite imagery and supervised classification. Since then, I've been tinkering with remote sensing for invasive species. And while working on my second master's degree, I decided to use my capstone project to explore searching for invasives further. Ultimately, I discovered that it was possible and my project was successful, but that going forward, if it was going to be scaled in any way, I would need some help of some wizards. Enter the wizards. KCI took up the challenge to develop a tool that could identify specific species. At the same time, we were getting KCI's drone spray program off the ground. Drone pun intended. We discovered that there was a lot of opportunity for better data collection. The data we collect and process with PhragFinder was intentionally designed to be compatible with drone sprayers. However, it is also compatible with most GPS systems. The old way of doing this was either your team hunted and killed on the fly, or you sent someone out with a paper and pen to muck through a site and hopefully not get lost. As time's gone on, we've added tech like handheld GPS models, field map apps on our phones, or using satellite imagery when we can't leave our desk. This is great and is tried and true, but it can lead to issues. In my screenshot, this was an area that was likely mapped based on outdated satellite imagery. We were contracted to treat the cell with a spray drone but found that the phragmites had significantly expanded beyond the designated area. So we weren't able to treat all of this area out here because our treatment permit was not set up to allow us to have that flexibility. We had a very confined area that the permit allowed us to treat. So our treatment line ended right about here. And that across this whole site, there was several acres of phragmites that we were not able to treat because of outdated information. Drones, of course, are the newest tool in our belt, and this adds a factor of how we assess all of that imagery now. So rather than fighting through the thorns and the muck and the snakes and the gators and the spiders and the ticks, so many ticks, We can pop a drone up and just easily cover 100 acres in less than an hour. The simplest imagery we can get is like this, which is an oblique. Great for expanding ground truthing and expanding your general perception of a site. With an image like this one, we can tell where we have been and task a team to start working on the next section of, in this example, reed canary grass. But the most complete data that we can collect are orthomosaics. These are stitched together images that create a high resolution, up-to-date image of your site. Once we have our orthomosaics, there are a few different ways we can create polygons. We might print it out on a piece of paper and Sharpie it on, where we want our teams to treat, or we can take these orthomosaics and import them into our preferred GIS system and then draw out polygons by hand, vertice by vertice, which can take, or we can start using an AI.
Thanks, Samantha. I really appreciate that explanation of all that you've done with drone technology. And yes, this is exactly how PhragFinder was developed. PhragFinder is a machine learning model that uses instant segmentation to detect those invasive phragmites from drone imagery. So that means no more drawing polygons by hand. Instead, PhragFinder quickly processes large volumes of imagery, identifies the phragmites, and generates GIS-ready DXFs and shapefiles that clearly outline the location of phragmites, delivering environmental services professionals like Samantha with the data that they need to treat phragmites effectively. So here is a great example of how PhragFinder fits into the invasive species workflow. As Samantha has described, in a standard workflow using drones, a drone pilot will fly an entire area using a drone, and once that data has been captured, a professional consultant needs to analyze the imagery, identify the areas of phragmites that need treatment, and oftentimes manually draw polygons around each of those areas. Those treatment zones are then exported as shapefiles that can be used for treatment by a boom-mounted sprayer, a backpack sprayer, or a drone sprayer. It's time-consuming, tedious process, especially when the drone is capturing a vast amount of data. But you see the difference with using PhragFinder in this workflow. All that laborious manual identification is done automatically, speeding the workflow and freeing up resources. PhragFinder is offered on the BRYX cloud platform. It is our secure and scalable platform that offers a variety of pre-trained AI models for different industries, including environmental, also construction, transportation, wastewater, and power. And with BRYX, you're able to get your results right away. So instead of needing to, for example, send your data out to a service and wait days, if not weeks, for the results of that data processing, on gobryx.com, you have everything you need to get started right away. And now I'm going to pass it over to Carl, who is going to talk to us about the technology behind PhragFinder.
Thanks, Catherine. Well, as everybody might imagine, the processes for building automated machine vision systems have evolved pretty rapidly in line with what's going on in AI. We use a system that supports our ML ops process. That's the machine learning operations that are involved with building these models. And I've got kind of a simplified, three-step process here. I'll try to go into a little detail on each one, but We start the process for any vision application by identifying imagery that we can use. In this particular case, that was very straightforward because Samantha was already collecting that imagery in drone deploy and doing things with it like annotation, et cetera, using it for flight planning. So we had a ready cache of data to use. We were able to download all of that information and then plug it into an annotation engine that is part of our MLOps system that allows us to do very detailed annotations of the imagery. And you can see one there under annotated imagery that it's highly detailed. We create it by literally sweeping across features of interest after we identify them. You might be curious to know that a group of computer science type people were responsible for identifying these features. And we had Samantha as our quality assurance person. So as we swapped them out, we kind of gave her a bit of a break from having to stare at her own imagery. And we got better at identifying the phragmites that was actually in that imagery and were able to annotate it. But Samantha kept us honest through a QA process that was built into the review cycle and annotation. So we would identify the features, outline those shapes, and then classify them based on what we saw. The second step in that process was to train the model. So now that we have several thousand images that are all fully annotated, we can feed that to a training process that uses a pre-trained base model. Some people will be familiar with some of these pre-trained models, but it's important to pick one that's both flexible and under development because, as I said, the field is moving quickly. But we train to a base model, so we plug our imagery into that base model and then begin the process of training the neural network that underlies that. With a given base model, we're not retraining an entire neural network. We're really only training the last layer or two to change the output. So we select a model type, whether that's going to be object identification or in this case, instance segmentation for this model. Then we choose a base model, which could be something like YOLO or RFDeter now, which is kind of the latest, greatest model out there for vision. Then we divide that into a set of training, validation, and testing data so that the model itself can validate as it's going along. And then we initiate the training process. These training processes typically take on the order of 1 to 2 days on a backend system. So they're being trained in the cloud. So they're quite long computationally. You've probably heard a lot of discussion about the importance of GPUs to the whole AI trend that's going on. One aspect of that is in training. So we train the model. We get all kinds of metrics about how the model works. Our favorite metric and the one that the industry typically uses is MAP. That's mean average precision. It's a combination of precision and recall, and we make it available to adjust the trade-off between precision and recall to the user when they're running these models. Finally, after we're done training the model and we believe we have a valid working model, we test it. Again, within our MLOps environment, the testing is made easy by preserving ground truth in the testing data that we have that the model was not exposed to. And we can just page through that data looking at what was successfully identified, where the lapses were, and go about the process of refinement. So it should be a big arrow from testing the model back to annotating where we refine the model. And over time, we get better and better performance on these models. So that's pretty much the MLOps operation and how we build these models. I'll turn it back over to you, Catherine.
Thanks, Carl. So when you registered, you did answer a variety of questions about your challenges that you were having with invasive plant control. And we wanted to make it really clear to you and stress in this webinar how PhragFinder absolutely does address those challenges. So for large scale coverage, you can cover large areas much faster. PhragFinder is designed to process large volumes of data with very high speed performance. So something that usually takes someone 4 hours to manually draw those polygons around the phragmites, PhragFinder can do in a matter of minutes. PhragFinder is also providing automated acceleration for you. So your important time won't be taken up by having to visually identify phragmites and draw those polygons. Instead, PhragFinder is saving time and resources, in which reduces costs. And finally, ready to run. That's a huge selling point of PhragFinder. You don't need to have to worry about training your own AI model or developing the infrastructure to run the model on in order to adopt emerging technology into your workflow. PhragFinder, as Carl had explained, is pre-trained with thousands of images and is ready to run on your data just by essentially uploading your data to BRYX. So at this point, I will stop. Oh, got someone else coming in. I will stop sharing my presentation and show you what it's like to actually use PhragFinder. And then after that, I'm going to hand it back over to Samantha, who's going to talk about PhragFinder results. So this is GoBRYX.com. This is our secure platform that provides a variety of pre-trained models that I had talked about for different industries within the larger architecture, engineering, and construction umbrella. For the purposes of this demo, we're just going to be talking about PhragFinder. You'll see now I've logged into BRYX and I have capabilities on the left-hand side that help me run my PhragFinder model. The first one is data sets. This is where you upload your imagery that you want to run through PhragFinder. And that uploading your data is as simple as just selecting the Create Dataset button. You can either drag or drop your files or browse your Explorer and bring your files in that way. Once your files have been uploaded and you've created your data set, then they are ready to be run through your BRYX model, in this case, PhragFinder. The other thing I wanted to show you is our results page. This is where all the results of our model runs, so for example, PhragFinder, appear. So we allow people to easily access their results, view them, and also download them. So to run PhragFinder, you click your Start button, you select the data that you're interested in running through PhragFinder. In this case, I've created a data set called Drawn Imagery. Select Next. And here you can select a friendly name for your PhragFinder demo. You can adjust your precision recall here, depending on whether you want to minimize the number of false positives or actually maximize true positives during your detection process. Select Next. Here you can review all of your parameters, the data that you're running, running through the model, and then select Run Model. And you'll see that when on my results page, this is configuring right now, but when it's done, you'll be able to access your results and download them easily.
All right. Thank you for doing that demo. So do you all remember this image? It was on one of my previous slides. So this is what that area looks like when it's been planned to be treated in the spray drone. That's what you see on actually on the drone controller. And the yellow lines are the planned flight routes. This is what we actually did. So it lines right up with those flight routes. And as you can see, this is a snip from my drone imagery. There's very clearly phragmites there, and you'll have to trust me when I say it aligned better in real life than it does on there. I didn't actually miss this of that. And then here we have an area that I manually delineated as well, just like I did in the other image. But, there's not much there, right? Well, this is what we actually treated out in the field. And we were able to make these adjustments, but had we had PhragFinder, we would have been able to make those adjustments before heading out in the field. So you can see that PhragFinder found things that I missed in my hand delineation. And when we remap treatment area on the fly, that costs time, daylight, and good weather. So being armed with the best possible data would have saved us about 30 minutes on site in just this little corner of the site. And this was a site where our permit was written that we had flexibility in being able to make these types of adjustments. But if you had a situation where your permit was more restrictive, then we wouldn't have been able to treat all of this Phragmites, and we would have had to leave rather large cells of Phragmites out there. So having PhragFinder was a great tool for us in terms of being able to find some of these spots without having to spend hours looking at each little pixel trying to find the Phragmites.
All right, thank you everyone to present the what is the PhragFinders to everybody here. So from now on, we would like to take a question, and I already seen that there are so many questions that people are already asking. So hey, KSI team, let's answer the questions one by one. It's in the Q&A sessions.
Yeah.
Okay, this is fantastic. I'll read the questions from oldest to youngest, and then Carl and Samantha or myself could jump in. Lauren asks, how tolerant is the model of differences in the appearance of the target species under different lighting conditions or at different times of year?
So I can answer some of that, and Carl might have some thoughts on it as well. But we have found that at least in the Midwest growing season phenotype, that in June and into July has been the best time for us to be able to pull out that data. When we start getting into September, late September and October, the Phragmites has senesced and the surrounding communities are senescing down to about the same color palette. It makes it a lot more difficult to identify Phragmites based on color.
Yes, and we do. I just wanted to mention, Carl, that on the Phragmites details page on BRYX.com, there are some notes on the type of imagery that the model works best on.
I was going to just mention that's a really good question, about lighting and stuff. The way we handle that on the training side is through augmentation. So we do hue, saturation, brightness, and exposure modifications to the imagery to augment the image set, and that significantly enhances our ability to generalize over what we're seeing.
Next question was from Chelsea. How does PhragFinder distinguish between phragmites subspecies?
So unfortunately, at this point, PhragFinder cannot distinguish between the native and invasive phragmites. There may be some difference between how dense the native is growing. I know there are a couple places up here in the Midwest where it does grow just as dense as the native stuff, but in general, it tends to not be quite as dense, so it's not going to give quite as robust return. But yeah, unfortunately, we don't have a way to tell the difference yet.
And another question is, what is the minimum stand size that PhragFinder will detect?
So we don't have a minimum size set yet, I don't think, Carl. We have seen it pull out some small patches of phragmites in terms of, they're maybe what, 10 foot by 10 foot.
Yeah, right. I mean, there is technically the minimum stand size is going to be defined by the camera and the height you flew. But practically speaking, because the sprayer itself only has a certain level of physical resolution, so to speak, width on the ground, we really comb out the small stuff that it's picking up, but it can pick up, depending on your resolution, it can pick up an individual plant if you go that far.
All right. And does BRYX hold on to client imagery data after it has been uploaded? And does PhragFinder require processing imagery into an orthomosaic prior to uploading? Carl, did you want to handle that second question?
Yeah. Yeah. Do you want me to handle both of them or just the second one?
Well, you can get started and I'll add anything if you.
Okay. Yeah, as far as holding on to client imagery after it's been uploaded, we do store it in the cloud. It's in your account. We do not have access to it. Sometimes people are surprised and ask us, what do you mean you haven't seen our imagery yet? But it's your imagery. You do have the option of sharing that imagery with us if you're interested in kind of supporting the growth of the model, because as a machine learning model, it's always learning. We do something called active learning. And so we love it when clients are willing to share data with us, because it goes straight into the active learning cycle that we can use in future training. As far as it requiring an orthomosaic prior to uploading, we can process either. We can process an image, we can process video, we can process an orthomosaic that's been tiled. There's a lot of things that we can handle. I think we specify as our input a TIFF image, and Catherine, you correct me if I'm wrong there, but the TIFF imagery is what we anticipated people would be wanting to provide.
Right, correct. From Maureen, these are great questions. Keep them coming, guys. From Maureen, what resolution and bands are required in the drone imagery?
So I'll start that off and then Carl can kind of finish it. I flew all the imagery that we used for training with a Phantom 4 Pro version 2, which has a 20 megapixel camera on it. So just your standard drone imagery camera works pretty well. So we did not specify specific bands. We also flew at about 300 feet. One project we did fly a little bit lower, but 300 feet is what we have been flying these other sites with.
And Ashley had a question kind of similar, but can you share more about the specific type of images data that are needed to run through PhragFinder? I think Carl addressed that. What image bands? Samantha answered that. What image resolution do the images need to be stitched? And I presume geo-referenced.
Carl, do you want to answer that?
Yeah, that's true, because we want to output shape files that are meaningful in terms of your location. So we do need that data.
Oh, Johan is asking, will the model include other species in the future? I'm calling in from Europe, and this type of automated delineation might become important in the future, but it would require training for other species which are more relevant here. I can answer that by saying, yes, we would definitely like to. We started with phragmites. We definitely like to expand to detect other types of invasive plants. And Johan, if this is something that you're interested in, I would love to follow up with you on that and see what your specific species needs are.
I might
And-
jump.
Yep.
I might jump in there as well, Catherine. That's a great question. We actually started this project as part of our innovation incubator, and Samantha provided us with reed canary grass samples. So we were working on that, and just about the time I was getting good at reed canary grass identification, we found out that Phragmites was a lot more of a target for us, and so we switched gears on that. But yes, we have considered multiple species, including, I think, purple loosestrife as well, right, Samantha?
Yes, purple loosestrife, reed canary grass. You mentioned the EU. I know Japanese knotweed is a big problem for you guys out there. It's becoming a big problem for us here in the Midwest as well. So put that on Carl's to-do list as well. If we can get the data for it, I would love to get started training on it. And someone in the comments is mentioning Arundodonax, which is also another gnarly cane species, which, yeah, we could definitely start working on that as well. And Ashley's mentioning buckthorn, all the buckthorns. Yeah, those are pretty gnarly as well. So.
All right, there's in the Q&A, there's a comment from Matt. Could PhragFinder also be trained to detect other invasives like narrowleaf cattail or reed canary grass? Well, we were just talking about reed canary grass, so yeah, yes to that, Matt. All right, I think those were all the questions. Does anyone have?
There's a couple in the comments that didn't make it in the QA, looks like.
Maya says, I'm curious, the variety of areas, climates that were QA'd, is the model accurate across Southern California versus Washington versus Montana?
Our training data has been a little confined to the Midwest. We have put in some data from the Carolinas, but in general, it shouldn't affect the model too much, assuming that you still have stands of Phragmites. As long as your Phragmites is growing in the same way that it grows here, which from what I've seen, where Phragmites is a problem, it's because it's growing in very dense stands and it still puts off that bright green coloring. So it should, but we have not had data provided from California, etc.
Thanks, Samantha. And I think the only other one that I missed that hasn't already been answered is Chelsea had some good ideas for how to distinguish subspecies. I was wondering if you had any thoughts on that, Samantha, if you're able to read that. Adding color to the model.
Yeah, so no, we haven't started on that, but that's a great idea.
Okay. Well, I wanted to, oh, sorry, Jay, did you want to say something?
No, I wanted to say thank you, everybody. I mean, we have a lot of questions. I think we did nice jobs to raise you guys' interest and want to apply your own data into PhragFinders. So if you would like to try out, and it is free, please reach out to me. My name is Jay Kwan, and you see my email address on the screen. Also, if you like to work with our KCI land management team or the drone spreading team with the scientists, then here is a QR code that you guys can capture and can work with our KCI service teams too. Is there anything that you want to add on to it?
No, that was great. I just wanted to mention that you can find PhragFinder on BRYX. Again, reminder, gobryx.com is our address for that. So
Yes. So that being said, we want to say thank you for joining with us, and I will follow with you guys individually. And if you have any questions, feel free to reach out to us and go to our website and try out the FlagFinder. Thank you.